Today, we will still talk about Venn diagrams, but now we're going to pay more attention whenever there's probability involved, which is going to be event and probability. So it is still Venn diagrams, but we're going to take a deeper look into it. Now, the main idea for today is that we can analyze the relationship between groups when data is being given using the Venn diagrams. What this means is that we can actually put numbers when we talk about Venn diagrams. It's not always going to be just to shade the correct region or not. Today we will see how can we use numbers when we talk about Venn diagrams to really have an understanding about a given scenario. So let's get started. Now, here again, the first thing you should always do is get familiar with the scenario. So let's take a look at the scenario now. Here, what we have is the following. We have that there's a school which has 1,000 students. Now, some students enjoy different sports. Now, some enjoy soccer and some enjoy basketball. Now, we know that there is exactly 200 students who enjoy soccer. So, 200 students which enjoy soccer, and there is exactly 50 students who enjoy soccer and basketball. So they enjoy both of them. So let's do that actually in a different color because that might be confusing. So let's do that in orange here. So we have 15 who enjoy soccer and basketball. And we have exactly 150 who enjoy just basketball. So now our task is to just answer the following. Well, we want to figure out those students who only enjoy soccer. So how can we figure this out? Well, whenever there's numbers involved, let's actually just put them in the circles. Let's put them in the Venn diagram. Okay, so what do we know? In a school, there's exactly 1,000 students. So let's put that here. The total, it always goes outside. So we know that there's exactly 1,000 students. That's what it says here. In a school of 1,000. Cool. So now, there is a total of 200 who enjoy soccer. So in the big circle for soccer, we know that this big circle has a value of 200. So that circle has a value of 200. There is 50 who enjoy soccer and basketball. So that means that here in the intersection, this has a total of 50. And here, 150 for those who enjoy basketball. Okay, excellent. So here, there is 150. So let's just put it the numbers here. Now, why is this helpful? Because first, when you understand the scenario, just shade the region and figure out what you either need to add or subtract to obtain that region. So here in example A, we want those students who only enjoy soccer. So just those who enjoy soccer, not those that enjoy soccer and basketball, just those who enjoy soccer. So let's see, which region will we be interested? So here's the soccer region. Well, we don't want to take in consideration this small region because here we have students who enjoy basketball and we only want those who enjoy soccer, just soccer. So this is the region that we're interested on. This region talks about those who just enjoy soccer. How can we figure out this region? Well, we know that the whole circle is 200. We know that the small intersection is 150. So that means that the small region here is going to be 200. So let's write that down here. So we know that it's 200 because that's the whole circle. And you want to eliminate the small region, which is 50. So that means that we have a total of 150 students who just enjoy soccer. So here, our answer is 150. Because again, the whole circle itself is 200. If we just want this region, we need to subtract this small section, which is the intersection. So that's how we got 200 minus 50. Now, Here, we just want those students who only enjoy basketball. I'm sorry. So now, again, which region are we interested on? So here's the region for basketball. We want those who only enjoy basketball. We don't want anyone who enjoys soccer as well. So this is the region that we're interested on. This is a region that talks about just basketball. So now, how do we find out the value of that region? Well, we know that the whole circle itself is 200. That's what we wrote here. We know that the small intersection is 50. So if we want to figure out the value for this section, that will be 150 because that's the whole circle minus 50, which is an intersection. Now this gets me a total of 100. So that means that there's only 100 students who only enjoy basketball. Now, if we take a look at the following example, again, the first thing that you want to do is just get familiar with the information that is given to you. So let's read. Now we have that when an animal is selected at random from those at a zoo, the probability that it is North American is 0.65. All right. So if it's from North America, the probability is 0.65. Let's keep reading. Now the probability that is both North American and carnivore, so North American and carnivore, is 0.16. And the probability that it's neither American nor carnivore, so American nor carnivore, is 0.17. Now, we want to use the Venn diagram to calculate the probability that a random selected animal is carnivore. So let's just identify what region are we interested on. So this, we want those which is just carnivore. So that means that this is the only section that we're interested on. We want to find out what is the value of just this section, because this is the circle that talks about carnivore. All right, excellent. Now, how can we find that out? We know that when we're talking about probability, if you add all the probabilities, it should always be equal to 1. So that means that here, this whole experiment, if you add all the probabilities, if you add all the circles and also the outsides, it should always be equal to 1. So if you add all the circles and all the probabilities, it will always be equal to 1. So that's one thing that we need to take in consideration, because here we're talking about probabilities. So we know that if you add all probabilities, that is equal to 1. So how can we figure out this small circle? Well, notice that we can figure out this whole circle if we get the whole square, which let's do it in green. So this whole square, I know that this whole square is equal to 1 because we just talked about it. If you add all the probabilities, it is always equal to 1. So this whole square minus the inner circle minus the outside. So notice that if we subtract everything that I'm doing in yellow here, what are we going to get left? We're going to get left just the red one, which is exactly the region that we want. So here's a strategy. How can we figure out the red section? We're going to get 1 minus each of those regions. So let's erase this. So here's what we have again. We're going to get 1, which is the whole thing. We know that the whole circle, or the whole square, I'm sorry, is equal to 1. Because when you add all probabilities, that's equal to 1. Let's subtract this region. Let's subtract this region. But what do we know about this value? We know that the value for this region is 0.65. So 1 minus 0.65. And we still need to subtract everything that is outside. But what do we know about the value of the outside? The value of the outside is 0.17. And here it is 0.17 because we know that that's neither American or carnivore, which is just everything else. So we know that the outside, so we know that if I subtract the outside as well, and notice that the yellow is what I'm subtracting, which is 0.17, what do we get left? We get just the red circle, which is exactly what we want. So all we got to do is just find out what's this value, which is equal to 0.18. So we know that here the inside of red is just 0.18. Now, here's your entrance ticket. Understand the following scenario and answer the following question.